we get started on the note sheet today, this problem here is not in the note sheet. It's from the first homework on 8.1. Yes. Yes. I want to go over this problem here from the homework from 8.1. So this isn't in the note sheets, but it is off the homework assignment. And this one here, the reason we're going over it, it's a little bit different because how many variables do we have here? Well, we have it in two different locations. We have the same variable, but it's in two spots. Because in this first triangle here, you're good. We do have y and y minus 1. They are in the same triangle, so we can have y and y minus 1 in both of the numerators. Yeah, so this is off the homework, so it's not in the note sheet. Now, since y is the slant here, it's going to match up with 18. And the y minus 1 is going to match up with our 16. So I wanted to show this because it is a little bit different. Because in all the ones that we've had so far, we've only had a variable that'll show up in one of these four spots. Now, because we do have variables in the different places, first off, we're going to have to multiply both sides by 16. Because if I multiply both sides by 16, here the 16 and 16 will cancel out. Will the 16 and 18 simplify out completely? Well, no. So, well, we're also going to have to multiply both sides by 18. Well, now we have 16 times 18 times our y over 18, but the 18 and 18 here will cancel out. Now, for a lot, I mean, in this Kendall's class, you probably cover this as cross multiplication because we can cross multiply, and that's essentially the same thing. And what that leaves us with is 16 times y is equal to y minus 1 times 18. So the main trick for this after getting it set up is really multiplying both sides by the two denominators. And for the first part here, we can go on and distribute 16 times y is, well, 16y is equal to, here, when we multiply through with 18, 18 times y is 18y. 18 times negative 1 is going to give us negative 18. Now at this point here, we do need to get y by itself, so we would subtract 18y from both sides, which will tell us that negative 2y is equal to negative 18. And last but not least, we would both sides by negative 2, telling us y is 9. So I was looking back at the homework assignments and noticed this here, so I thought it'd be helpful if we kind of went over it so that y'all can see how this has worked. Any other questions on this one here or any of the other homework assignments? Because y'all have had two so far, 8.1 and 8.2. Now, where we left off on Friday was this problem here, where we're using side-side-side similarity, where three sets of proportional sides, if they are congruent, then we can say the two triangles are similar. Now, we did one of these on Friday, but we need to find the value of x that will make these two triangles similar. Now, we can use the similarity statement to match up the sides. So we have triangle XYZ is similar to triangle HJK. Well, the first two that we have is XY is matched up to HJ. We also have that JK matches up to YZ. And lastly, HK matches up to XZ. Now, in all of these here, we do have two spots where we do have a variable, because we have the 5 times x minus 6, and we have the x minus 5. And we need to solve one of these for the value of x. Which one do we want to use? 5 times x minus 6 or the x minus 5? Mm-hmm. And which one does it match up with? YZ, which is our 5, yes? Which other one do we have? Well, we have the x minus 5 and 30, yes? But hj and xy, so our 15 over 3, yes? Now, we put 15 on top because we use 5 times x minus 6 first. So since they're on the same triangle, and we put 5 times x minus 6 in the numerator, we'll put 15 in the numerator also, yes? Now, at this point here, we've always, or the last few, we've gone about multiplying, trying to get the variable by itself, yes? Can I divide 15 in 3? What is 15 divided by 3? 5, yes? Well, wait, can I simplify anything in the other one? Because here we have 5 divided by 5, yes? What is anything divided by itself? 1. So those will simplify to 1, leaving us with x minus 6. Yes, sir. Quickly. And lastly, what do we need to do? We need to and that's it. We can, because here it's just asking for what? The value of x. Now, if we did plug it back in, well, here, what times 3 is 15? 5. So we multiply by 5, yes? So 5 times 5 is what? We'll go in this direction. We wouldn't multiply by 5. We would. 30 divided by 5 is? Well, the value of x we found is 11, yes? So for this here, we're doing 11 minus 5, which is 5 times 11 minus 6. Well, 11 minus 6 is, and 5 times 5 is. So really, once we find that scale factor, we can go from one to the other. Well, we found the scale factor to be 5, yes? Well, our 15 divided by 3 gave us 5, the scale factor. Questions on this here? Now, the other side angle side, or kind of our similarity theorem that we're going to have, is this one here. Side angle side similarity. Now, this has 2 main parts to it. We're going to have 2 sets of proportional sides and a set of congruent angles in the middle. So the proportional sides have to be on either side of that congruent angle. If the proportional sides were these 2 here, this doesn't work. It has to be on either side of that congruent angles between the 2 triangles. So as long as we have a set of congruent angles and a set of proportional sides to either side of it, then we can say the 2 triangles are similar by side angle side. So we're looking at this here. So you're building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it's similar to the left end using the length shown? So really all we need to determine, are those 2 triangles similar on either side? Well, we're given 2 sides and an angle, so we're looking at side angle side. So a side, an angle, and a side. Do we have a set of congruent angles? So we could say angle F is congruent to angle A. Now we just need to determine if our two sets of sides on either side of that angle are proportional. So in one of the triangles, we have side lengths of 6 and 10, and the other we have 9 and 15. Which one of these four side lengths do we want to use first? So we can say 10, yes? And 10 corresponds to our 15, because it's the bigger of the two. 10 is the bigger of the two between 6 and 10, yes? And 15 is the bigger one on 9 and 15. And exactly this does reduce to 2 over 3. Why would I need to do 6 first? Exactly. Because I need these proportions to be the same. Since I used the 10 first, I've got to use the 6 first. And 6 over 9 does reduce to 2 over 3. So we do have that we have two sets of proportional sides and a congruent angle in the middle. So can we say that these two are similar? Yeah, by side angle side. And that's it. Any questions on this here? Okay, let's look at the next one. I think we just have 2 left, don't we? Now, looking at this one here, we have 3 different ways that we can show similarity. Angle, angle, side, 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 angle, side are the 3 ways that we have, yes? Are we given at least 2 angles in these 2 triangles? No, we're given 1, yes? Am I given 3 sides? No, so we really can't use these 2 here. We technically could use side, side, side because it is a right triangle. If we wanted to use the Pythagorean theorem, we could find the third side lengths, but we're not guaranteed that the third side lengths of these here would be nice. We could be looking at answers with radicals because it doesn't simplify. So, I mean, we could use side, side, side. But the last one, side, angle, side, am I given 2 sides with an angle in the middle? Okay, so why use Pythagorean's theorem when we have another way that works just fine as is? So let's use side, angle, side. So angle R is congruent to angle, because they're both right angles. Now we just need to make sure the sides are proportional. So we have side lengths at 24 and 28, 18 and 21. Which one do we want to use first? 24? So 24. Now its corresponding side would be 18. Because 24 is the smaller on its triangle, 18 is the smaller on its. Now we can plug this into the calculator to simplify it, so we can actually compare the ratios better. And this would be, I think, 4/3. Because they both have a common factor of 6. So we get this here. Now what's going to be the numerator of the second fraction? Since we used 24 first, the other side on its triangle is 28. And we're going to have it over 21. Now 28 and 21 have a common factor of 7, which reduces to 4/3. And that's all we have to do for this here. Yeah. Explain how to show that the indicated triangles are similar, side, angle, side. We said that R and N are congruent, that's our angle. And we showed that we do have one set of sides, but both sets of sides are proportional. Now, let's see here. Nope, erase this here. Really, if we wanted to, back it up. Okay, erase that. Now, what I could do, and what we could say, let me grab this, move these over, is that for 24 and 18, we could have said SR over PN, and here NQ and RP, if we wanted to make it more precise, is just adding in those links to compare them and show, okay, that these are proportional. But that's all we would need. Let's look at number 4, the last one here. So, do we have two angles in both triangles? Well, we do have the right angles, yes? Do we know any of the other angles? Well, no. I mean, we could technically find them because of our trig inverse properties. We could go backwards and find those. But again, that's going to be more work to try to figure out what the angles are. Are we given 3 sets of sides in both triangles? Well, yeah, we can go on and use side, side, side. Why try to find the angles if we're already given 3 sets of sides? Now, looking at our two triangles here, so we're looking at X, ZW, X, ZW, and YZ, X. So, if we're going to look at these proportions and seeing if they're all the same, we need a side length to start with. What length can we start with? 15. Now for this triangle here, XYZ, is 15 the smallest, middle, or biggest side length? Biggest, because the side lengths are 9, 12, and, guys, put it away. Thank you. 15 is the biggest from 9, 12, and 15. If we look at the other triangle, XZW, which one is the biggest? 20. So we're looking at 15 over 20. And 15 over 20 will reduce to 3/4. Okay. 3/4. Okay, pick another side length on XYZ. 9. Now is 9 the smallest, middle, or biggest? Smallest. So what's the smallest side on the other triangle? 12. So we have 9 over 12. Which will reduce to 3/4. What's our last set of side lengths? So 12 over, which reduces to 'So we have 3 sets of sides that are proportional. So the two triangles are proportional to each other. And the only way that we could have made this a little more mathematical or technical is just adding the side lengths. So XY, XW, YZ, XZ. And the last one would be XZ and WZ. That's the only way we could have made this a little more significant. Therefore, since the 3 are equal to each other, it means the two triangles are similar. Any questions on any of this here? So, what we've covered in 8.2 and 8.3 are these 3 properties here. Our angle similarity. That if we have 2 angles, 2 sets of angles that are congruent in the 2 triangles, then the 2 triangles are similar to each other. Side, side, side similarity. If we have 3 sets of proportional sides, then we can say the 2 triangles are similar. And lastly, if we have 2 sets of proportional sides with a congruent angle in the middle, we can say that the 2 triangles are similar. And these are our 3 main ways of showing similarity. And that's it.